Swayam Prabha. Digital India. Educated India.
Hello everybody, welcome to the last lecture in the course Computer Integrated Manufacturing. Professor Ram has just discussed the future aspects in SIM. I like to take this lecture further and like to discuss about 2 or 3 more concepts which are coming up in the future, which are now in the incipient stage in Computer Integrated Manufacturing. So, this is the last lecture. I am Dr. Ramandeep Singh. So, I will discuss about big data, that is one of the important things, and how do we cater the problems in big data, how computers helps in recording, then analyzing and drawing inferences from the large amount of data. What is big data, that we will see. Then I will try to discuss about these 2 aspects, virtual reality and augmented reality. Then also we will talk about cyber security. VR and AR are close to each other, and how does they interplay with each other, that we will see. Just to recall, industry 1.0, 2.0, 3.0 and 4.0. 4.0 is now what we are in. Industry 1.0 was just the start of the industrial revolution, that was just the end of 18th century, when mechanical design was there and water and steam was used for the production. That was industry 4.0. Here we used water and steam. Then came industry 2.0, where electrical energy was just being used in industry. Through the introduction of mass production based on division of labor and some management concepts, scientific school of management, that was actually way before the classical school of management, the scientific school of management took place, then HR school of management came into play. So, that was the industry 2.0. Then electronics and IT, we can say that was introduced in industry 3.0, electronics and information technology. That is industry 3.0, where it was the duty of robots to automate the system. So, IT systems automate the production lines, and further it started working. Now, we are in industry 4.0 that we are discussing, in which we have the concepts that we have already discussed, like IoT, then we have virtual reality, augmented reality. So many things are there. In industry 4.0, Internet of Things, cloud computing, cloud technology automates the process. Artificial intelligence is the one that is covering all this. AI. This is industry 4.0. Now, what is big data? In most enterprise scenarios, the volume of data is too big, or it moves too fast, or it exceeds current processing capacity. So, what is big data? Big data is the large amount of data. Data can be available in many forms. We have discussed the difference between data and information. Data can be structured and unstructured as well. Data is already there, there is so much of data, but the data is not in the structured form most of the times. So, what is big data? The large amount of data that is there, that is not in the structured form, but it has some important information carried in. Now, that information has to be extracted, and that information has to be used to have the future forecasting, to have the secondary information. How do we address big data aspects, that I will discuss very briefly here. Big data is a field that treats ways to analyze, systematically extract information from the data sets that are too large or complex to be dealt with by traditional data process application softwares. Now, big data, number 1, analyzes data, then number 2, systematically extract the information. These 2 are the important concerns that are taken care by big data. Big data is a phrase used to mean a massive volume of both structured and unstructured data that is so large that it is difficult to process using conventional database and software techniques. So, what we need to do, if you talk about the data or in analytics, analytics can be majorly classified into three categories. One is descriptive analytics, predictive analytics and prescriptive analytics. What is descriptive analytics? We just need to describe the data. Describe the data, we know the general things, mode, median, mean, those all these things, then variance, etc. Then is predictive analytics. In predictive analytics, we do forecasting, we do analysis of variance, these are all statistical terms. In prescriptive analytics, we come up with some prescription, we come up with some outcome from the data that we have analyzed. So, this also happens in big data. So, big data challenges include capturing data, data storage, data analysis, data search, sharing and transferring of the data, visualization, querying, updating information, piracy and data source from where the data is taken. So, when we talk about big data in this way, there are so many parameters those are to be taken care of. To divide it into major 5 factors, I will pick this illustration in which 5 V's are there. We have volume, variety, value, velocity and veracity. Volume, big data by name itself, big means huge, means tremendous, huge amount of data is there. The variety, different formats of data are there, data is available in graphical format, in charts, in literature itself, in the form of text, so many forms of data are there. Value is the final result that we are trying to extract from the data. Data is both in structured and non-structured, as I just said before. So, the data has to extract some information, then value has to be taken from that. Velocity, data is moving at very high speed, the high speed of data accumulation is there. Veracity, inconsistencies and uncertainty in data is also there. Okay. If I take an example of medical devices, in medical devices those can be divided into major 4 categories, classes A, B, C and D. A and B go inside the body, B, C and D remains just on the skin. Is suppose a new improvised medical device has come that is a little more innovative, that goes wrong in some way, we have to track from where all the components which are manufactured, all the materials with which the component is manufactured, who has manufactured that, we will track all those things. The IOS systems helps in them. So, to track that where that this component of the medical devices has come from, we have to have all the information to through whom this component came through, who manufactured this, what is the time taken by this, and all the laboratories those have tested this were certified or not, all those things has to be there. So, this became this. So, for a simple product I could say the data, the volume that is there is too heavy. So, we have to take care of all those things. So, this is big data. So, next I will like to discuss cloud computing, but what is the cloud and big data? Let us see. Big data refers to voluminous large sets of data, whereas cloud computing refers to platform for accessing large sets of data. So, large set of data, when big data we talk about the analytics, data analytics as I just said, both or all the 3 types, descriptive, predictive and prescriptive kind of analytics is used, and cloud computing is just a platform which is in which cloud is used, as we took the example in our Fusion 360 software, in which all the computation was happening on the cloud. So, cloud computing is a platform where the data could be kept, assessment happens there, and we do not need to have very high end or very fast running computational hardware with us. So, in other words, big data is information, while cloud computing is means of getting information. Advances in connectivity, cloud computing, big data and expansion of the IoT have opened the door for a new breed of intelligent manufacturing technology. Now, what are the differences between cloud computing and big data? This I like to cover very quickly. First is the definition. As just defined, big data and cloud computing differ in a way that big data is information, that is large amount of information. However, cloud computing provides the resources or software tools to assess the data or analyze the data. So, I will just jot down the differences. Next is the references. When we refer big data, we are talking about the structured and unstructured data. It can be in structured and unstructured form. So, further this tree can go further structured and further primary, secondary, so many kinds of data sets could be available. When I talk about the reference for cloud computing, it only differs in a way that what is being provided, SaaS, PaaS or IaaS. What is SaaS? SaaS is a software as a service, PaaS is a platform as a service, and IaaS is infrastructure as a service. And how to use big data, or how to use or where to use cloud computing, how to use, if I say this. So, this big data can be used both offline and online. However, in this it is online or wide range of services are required, wide range of servers, that is online and mostly internet is required for this. Then format for big data, we have SAP software, we have MathWorks. I am just listing a few very common used MathWorks, then MATLAB, not to forget. There are so many softwares are there, then SPSS, so many softwares are there that can be used for assessing big data, but this only using softwares or online platforms, I would say only online platforms. So, applications, big data does descriptive analytics mostly, so it describes the data. And provide useful information. However, cloud computing stores the data and process the data on remote service. So, these are the major differences between cloud computing and big data. So, let us discuss what is cloud computing again. In intelligent manufacturing, these are various actors which helps to work with it: cloud computing, Internet of Things, big data and related analysis services. So, what we have here? We have software, we have hardware, we have service. Software is a virtual reality, is a knowledge management system. Hardware are the robots or the computers which we use, the high quality robots or RFID or 3D printers, any machinery that we use, that is hardware. This helps us to provide services like producing designs for optimizing and designing operations and system integration and various consultancy services. So, this provides solutions to Industry 4.0, and this is known as intelligent manufacturing. So, this is intelligent manufacturing. Again, putting down the definition of intelligent manufacturing technology, what is this? Advances in connectivity, cloud computing, big data, expansion of IoT have opened the door for a new breed of intelligent manufacturing technology. So, big data, where does it help? It helps in risk management. In risk management, we are able to identify that what was the data, what was the structure or the behavior of the data in the past, and how in the future that would help. So, this helps us in forecasting the risk and build to order configuration. In inventory management, what is the amount of inventory to be kept? So what is the reorder level, at what point do we reorder the things, and what is the work in progress, raw material and finished good inventory are to be kept. So those things can be identified using big data, improving product quality, after sales services. This is very important. What have been the feedbacks of the customer for the previous product of the similar kind, and what are expected to happen in future for the products that is produced in the similar fashion. So those can be tracked. Then track daily production, then data driven enterprise growth, predictive and preventive maintenance. Maintenance is a very important part. From the past we can learn how maintenance is happening. People can assess the maintenance data from the past, and maintenance nodes, at what point the machine has to be completely reset, or the machine has to be taken care with some preventive or predictive maintenance, some corrective maintenance. Sometimes breakdown happens, that breakdown has to be avoided here. Then overhead tracking, then testing and simulation of new manufacturing processes. As I said in smart manufacturing lecture, in PLM software, those testing could be done in the software itself. Simulations can happen in the software. This big data, when so much amount of data is there, that can also help us to simulate what realistic or real system would look like. And then logistics, yes, transportation. In transportation, data is very helpful. RFID and QR codes, as we just mentioned in the previous lectures, is used here in manufacturing. Next comes virtual reality. I'll discuss about two major kinds of the technologies here. One is VR, second one is AR, virtual reality and augmented reality. In between them there is MR. MR is mixed reality. The definition of virtual reality comes naturally from the definitions of both virtual and reality. The definition of virtual is near, and reality is what we experience as human beings. So the term virtual reality basic means near reality, that is close to reality. Actually what happens in virtual reality, we are trying to develop a three-dimensional system, that is computer generated system, which tries to imitate the real environment. This is a completely 3D system, like the 3D video games that you play. Those are kind of VR environment. So you can see the whole park, you can see the whole factory, the whole you can say when kings are fighting, you can see the whole army fighting. What are those things? And this is all virtual reality. The reality is being imposed using the computer. This is very useful in manufacturing as well. How does it happen? We'll see. So virtual reality is a term used to describe a three-dimensional computer generated environment which can be explored and interacted with by a person, or by a person. That person becomes part of this virtual world or is immersed within this environment, and whilst there is able to manipulate objects or perform a series of actions. I'll just show you a video here that is just taken from the virtual reality developers. We have taken permission from them. I'll show you the video here where both AR and VR are used in manufacturing, and how does that help in realizing that what would happen in reality. So as I said before, it is always suggestible to fail a simulation, to fail a VR system, to fail in an AR system, to fail in an VR system, than to actually fail in reality, because that financial loss could be very heavy. There could be harm to humans, there could be harm to the products those are manufactured, and that could be really drastic. So this is a VR system. In VR system, this human is completely immersed in a virtual environment. He is keeping a VR gear on its eyes. So this VR gear, you might have seen this, Samsung and Apple are providing this kind of virtual reality gears. So what is he doing? He is trying to connect the wires. He is just doing that in open air, and the connection is being happening. So in this case, the VR reader, this is kind of a, we can say, the inspector who is trying to see what are the features of the robot, what is the set information, what is the angle here, what is the bearing size, or what are the bearing types. All this information is displayed while he looks at the system. So this VR system is integrated with the realistic system here. So these are the major applications of virtual reality. So what is the technology behind virtual reality? CAD, it is obviously the CAD. Virtual reality is actually an extreme extension of CAD. It is the CAD taken to the extreme, and to develop the systems, to develop the environment in a way so that everything that is around here is similar to what in real life is. So, technology behind virtual reality is sophisticated computer aided packages and graphic programs can display realistic images on your computer. This is the rationale behind that. Now, VR takes this a step further, either by integrating the computer generated images with the real world, or creating an entirely new world, that is immersing the user in a completely computer generated world. Virtual reality entails presenting our senses with a computer generated virtual environment that we can explore in some fashion. This is the kind of testing that is happening in a virtual environment, that how the system would run, how the turbine would run, how would it throw the fluid in different directions. So, these testings can also be taken care or can be carried out using this VR platform. Now, what is AR? Augmented reality is an interactive experience of a real world environment where the objects that reside in the real world are enhanced by computer generated perceptual information. Now, in virtual reality, the operator or the person who is there, he is completely immersed in the system. He cannot see the real system at all. He is completely in the virtual system. Now, reality, augmentation of this reality. This augmented reality is the real system he can also see, but he can superimpose the virtual system on the real system. This is augmented reality. So, it can apply to multiple sensory modalities, including visual, auditory, haptic or sense of touch. An ogogram is a computer generated image that is used to create AR. AR can be defined as a system that fulfills three basic features. Number one, a combination of real and virtual worlds. Second is real time interaction. Third is accurate 3D registration of virtual and real objects. This is AR, augmented reality. You can see the person is standing in the real environment. He can see this door and so. He is just trying to superimpose his virtual system on this handheld tab and try to do some inspection, some graphics are being made. So, this is a kind of an OCR, optical character reader, in which the real book or the real environment is augmented with a reading system, or the diagram that is made on the book is developed in a 3D form using an AR system. Now, VR versus AR. In VR, the user's perception of reality is completely based on virtual information. In AR, the user is provided with additional computer generated information that enhances their perception of reality. This I have already discussed. In AR, the part of surrounding environment is actually real and just adding layers of virtual objects to the real environment. On the other hand, in VR, the surrounding environment is completely virtual. Now, AR versus VR versus MR. Now, what is MR? MR is mixed reality. What we have actually with us is, we have a real environment, you can say a real environment here, and we have the virtual environment here. So, real versus virtual. So, these are two extremes. So, when I move from real towards virtual, this is known as our AR, augmented reality. And when I move from virtual towards real, this is my augmented virtuality. So, AR, what we are talking about, is very close to the real environment. The most of the things, those you can see here is the real things, but AV is just a few things are real, but most of things are just virtual. So, in between them, what we have is the mixed reality. In between AR and AV, what we have is mixed reality, it is MR. So, this is mixed reality. The augmented reality alters one's ongoing perception of a real world environment, whereas virtual reality completely replaces the user's real world environment with a simulated one. AR is related to largely synonyms. Sometimes AR is also known as MR or computer mediated reality. So, these two words are sometimes taken synonymous, AR and MR. So, further about AR and VR and MR. In VR, we have fully artificial environment. In AR, we have virtual objects overlaid on the real environment. So, most of the proportion is here real, only virtual objects, that is you can see the images which are superimposed on your mobile or so. So, in mixed reality, we can work with both environment combined in the real world. So, we work with both of them. So, fully immersion in virtual environment in VR, real world objects enhanced with digital objects in AR, and in MR interact with both the real world and the virtual environment. Now, applications of AR and VR. In complex assembly systems, when the components in the system are too sensitive or there are so many components in the system, the number of components is too large, then in complex assembly as well, AR and VR used. So, this is AR system, augmented reality, in which the person is watching the door, he is getting the information, that the door is completely processed with all the steps before it, and now he is able to assemble that to the next point. So, modern manufacturing involves putting together hundreds or thousands of components in a precise sequence as quickly as possible. There are so many electronics, hardware and systems put in a door for an advanced car. So, all the systems are to be completely spot on. For that, this AR is also used. In maintenance, you can see the person can see that when for the replacing nitrogen tank, he can see remove supply line, he can see the steps those are to be taken care before actually doing or before actually operating the maintenance task here. So, it can aid in mechanics real view with text, arrows, animations that you can see here. Labeling of the components can be possible, real time diagnostic data is available, gesture tracking is there, safety warnings can also give some alarms here. Then it allows off-site collaboration. Then in expert support, experts can watch and supervise how the system is running. So, you can see the experts can watch the system, experts can just inspect the system whether the system is running right or not. This allows experts to offer support and perform inspections from anywhere. Rather than training every technician or machinist, companies could use AR technology to supplement their employees' existing knowledge with engineering expertise delivered via telepresence. Quality assurance. In quality assurance, AR and VR systems can help in a way that they can guide operations through inspection tasks and perform the actual inspections, identifying where parts are missing or to have been correctly assembled. VR reduces risk and can accelerate implementation by allowing engineers to quickly identify the problems. In automation, obviously this can be used in this automated system. You can see the person is using VR to see what is the distance that is taken, how the robot could pick the object. Both AR and VR helps in automating the process by using distance controlling. Then real world visualization, which helps in generating more accurate data, and together with the machine learning, artificial intelligence and deep learning, we can automate the whole process of manufacturing. So, in product design, there are so many applications in product design. Augmented reality can be used in designing cars, planes or any other products which has difficult construction. The big products like planes, ships or so can be produced using AR and VR environment. AR model helps to estimate the functionality of the design and can be used to optimize it. The main pros of AR here are: number 1 is better feedback, number 2 is better preview, number 3 is detailed models. In better feedback, it connects the designed objects with physical products. It provides both visual and digital data which help to improve design itself. In better preview, unrestricted realistic view can be cut mockups costs. Detailed models can be provided, such as 3D models in association with AR give the opportunity to see a clear look the future product without overlapping the program interface, not limited by the computer screen. So, these are AR and VR applications. In this is AR This is VR, this is completely virtual environment, this is AR. This in this AR we can see the objects superimposed in your house. It can be used in different platforms. You can use in an Android phone, you can use in an iOS or iPads. So, in so many systems this can be used. So, let me show you a video in which AR, augmented reality, is used using your mobile phone. So, I will take an example here. So, this is an office environment in which an app is installed on the Android phone, and augmented reality is used to superimpose the images and try to see that how the product would look like when you put it on your room. So, we have two options here in this environment, a faucet and a bathtub. This is on the left side we have faucet, on the right side we have a bathtub. This can be used to see how or what would the color of the bathtub or the faucet that you would like to install in your washroom. So, just to show the demonstration, the bathtub is superimposed. Bathtub is now clicked here. It is superimposed on the table or the computer table, office desk. So, good thing about this scenario is this: if you have customers walking in your office, the customers who are away from your factory, you can show them how the bathtub would actually look like. So, the clients might like this. This is a new way of advertisement. So, this is how sometimes in advertisement of the manufactured products, this AR is also used. The depth of the object can be very well seen here. The illusion is quite well here. So, next is faucet, left side. So, you can see this faucet. So, what would be the size of the faucet, how would it look like. So, AR helps in this kind of the simulation. So, we can zoom it and zoom out to look it. So, all the four sides you can look at it. So, you can make it to scale, you can zoom down, zoom up, you can zoom in and zoom out. So, you can see this is a trackerless AR, in which also you can see human hand here. So, it is trackerless AR. So, this was the AR environment where we saw the products, those can be shown to the clients. So, next I will show you the VR, in which if in the factory layout we can see how to use harness, how do we use small tools to carry out small maintenance tasks in the factory. So, this is the VR environment, let us see. So, this is a VR environment, you can see the human that is working here. So, they are acquiring the security apparatus here. So, required protocols are to be followed here. The belt with the harness is required here. They are tucking the harness, then picking the safety shoes, then goggles, then the drill is tucked here on the belt. Is it tucked on the belt? Yeah. So, open gate, it is showing the instructions what to do. So, before doing anything in the factory, one has to put the harness on the belt. Without putting the harness, one cannot move even one step forward. So, it is being latched here, the harness is moving, the human is working. So, this is completely virtual environment in which human is completely immersed in the environment and we cannot see any real object. You can see the virtual gear that the person who is operating is working with. This is designed by the same person. So, the harness is taken from left to right side. See, attached to belt, all instructions are being shown here. Then from right to left. So, in this these things can be done using both the hands. Now, there is something to be required here. So, it is they are taking out the drilling machine to perform the task. The drilling machine is unscrewing a screw from it. The task is performed, your task is completed. So, this virtual reality is used for the virtual environment. You can see you have completed the training. This is for the training of the people. So, this virtual environment is used for this purpose. So, we have taken examples for both virtual and the real environments. Next, I would like to talk about the topic that is cyber security. Cyber security is very important when we talk about computers in manufacturing. The computers are to be safe. In that way, cyber security is one of the important issues that is to be considered in future as well. So, in that, What we do, what is cybersecurity? Let us see first. Cybersecurity or computer security or cybersecurity or information technology security, that is IT security, is the protection of computer systems and networks from the theft of or damage to their hardware, software or electronic data, as well as from the disruption or misdirection of the services they provide. Cybersecurity is very important because there is more and more increased reliance on the computers these days, reliance on the computer systems these days. The internet and the wireless network standards such as Bluetooth and Wi-Fi are there, and due to the growth of smart devices including smartphones, televisions and various devices that constitute the Internet of Things, there are so many parameters where people, their Bluetooth is there, Wi-Fi is there, your hardware is there, your software system, AR, VR, so many systems are there. From any point, if we have anything loose, any loophole is there, the breach in the system could happen. So, owing to the complexity of the present day systems, both in terms of politics and technology, cybersecurity is one of the major challenges in manufacturing world. So, what cybersecurity has to look after? It has to carry out cybersecurity assessments, it has to secure configuration and design, cybersecurity appliances and softwares has to be designed, then cybersecurity monitoring and remote management systems has to be developed, then incident readiness and advisory system on advisory committees are to be developed or are to be constituted, proactive maintenance has to be carried out. In assessments, network and asset inventory has to be taken care, system anomaly and threat identification has to be taken care, global cybersecurity frameworks alignment has to be followed. In system configuration and design, architecture and configuration review, protocol and domain specific integration design, system hardening including remediation and updates are always very important. Like in your softwares as well, for your computer systems, for your CAD software, for the CAM software, the updates are very important to be taken care of, and these also helps us to keep our softwares from any breach. Then cybersecurity appliances and softwares, increased layers of protections are there in the software, best practices, implementation, library and tools, disaster recovery management system is to be there, application while listing, then secure immediate exchange, endpoint security, all those things have to be carried out. Then in remote management system 24/7 cybersecurity system environment has to be developed, then remote access and administration has to be instituted, automated patches and updates are to be there, then creation of incident response procedures are to be developed by the advisory, then the roles and responsibility of the people, then partial steps and disaster recovery has to be taken care, upkeep, the expert review and life cycle services are to be taken care. So many things to be taken care by cybersecurity. This is very also important in manufacturing. Cybersecurity threats may impact personal or financial information. The threats can be from many sides. Now, cybersecurity has become a critical component of effective management in manufacturing. There are certain kinds of threats. I would put threats here. So, what are those threats? It may cost manufacturer proprietary information, unique formulations in creating a product faster, identification of a product locations which could be used for stealing product during shipment, loss of control over the market and more asserts. Single breach destroys the perception of trust. As it is said, a single spark can burn the complete jungle. So, a single breach can destroy the perception of trust and rapport with the customers, and manufacturers could lose vital information about the key manufacturing processes, especially proprietary information. So, there are various ways the breach could happen. Let us see how this breach could happen and why the cybersecurity is important. By understanding the need of cybersecurity and how to monitor, create, analyze and implement cybersecurity measures, customers and the manufacturers can attain peace of mind in ever increasing. There are certain ways of security breach. It can be through a network, it can be through access of mobile, it can be through the training that is given to an unknown person, it can be responses made by the customers, the hard copies and removable media, computers, all these can pose threat to our cybersecurity system. How to implement a cybersecurity policy? I have just listed down the 5 steps. For more information, you can read the links, those are provided in the reference section of this lecture. So, to just jot them down, step 1 is to identify trade secrets and proprietary information. Step 2 is to identify where information from step 1 is located. Step 3 is label information from step 2. Step 4 is view cybersecurity from an attacker's point of view. Step 5 is make a cybersecurity priority across the organization. So, I won't go into detail of this, but you can definitely read about cybersecurity, security policy. This is a general, these are the general 5 steps, those are there to design a cybersecurity system. With this, my major topics are covered. Now, finally, how the evolution of technology came up with time through the million of years, from the very ape man to the final AI now. Actually, we are in this stage now. We are in this stage now where the humans can use artificial limbs and they can use the VR and AR tools. So, also we are moving towards, as predicted by many of the scientists, to the completely AI system, in which complete human body can be made in an artificial system. So, this is AI future, I would say here. So, with this lecture is complete. I like to quickly go through the course contents that we covered. To recapitulate the things that we covered, in the first weeks we covered the introduction to SIM and CAD and CAM. Now, SIM is a manufacturing approach of using computers to control entire production process. This integration allows individual processes to exchange information with each other and initiate actions. So, introduction to SIM was given in the first week. Then the forthcoming second, third and fourth week covered CAD and CAM. So, what is CAD? CAD is the use of computers or workstations to aid in the creation, modification, analysis or optimization of a design. CAD software is used to increase the productivity of designer, improve the quality of design and improve communication through documentation and to create database for manufacturing. Then the use of CAD can be made in CAM. CAM is the use of software to control machine tools and related ones in the manufacturing of workpieces. It may also refer to the use of computer to assist in operations of a manufacturing plant, including planning, management, transportation and storage. So, we discussed geometric modeling in CAD, geometric modeling, computer graphics and so on. We discussed CNC and CNC laboratory demonstrations and CAD laboratory demonstrations in computer aided manufacturing. Next, we discussed the computer aided process planning. So, in the process planning, we first discussed about the general process planning, then group technology and process planning we discussed. So, what are these? Computer aided process planning, it is a use of computer technology to aid in the process of planning of a part or product in manufacturing. CAP is the link between CAD and CAM, in that it provides for the planning of the process to be used in producing a designed part. Group technology, it is a manufacturing philosophy in which similar parts are identified and grouped together. This is done to take an advantage of their similarities in design and production. Group technology contributes to the integration of CAD and CAM. Next, we discussed about the components of a SIM system, computer aided manufacturing system. In the system, in a manufacturing system, we have FMS, flexible manufacturing system, industrial robots and PLC. What is FMS? It is a manufacturing system in which there is some amount of flexibility that allows the system to react in case of changes, whether predicted or unpredicted. Industrial robots help us to do the things that human could have done in their absence. An industrial robot is a reprogrammable, multifunctional manipulator designed to move materials, parts, tools or special devices through variable programmed motions for the performance of variety of tasks. So, this we have discussed, kind of the robots those are available, kinds of robots those can be built, kinds of the components in FMS. Then also we discussed the PLC. PLC is an important part of robotics. It is an industrial digital computer which has been ruggedized and adapted for control of manufacturing processes, such as assembly lines or robotic devices or any activity that requires higher reliability, control and ease of programming and process fault diagnosis. Next, we discussed about computer-aided quality assurance, in which we discussed coordinate measuring machine. Computer-aided quality assurance is engineering application of computers and computer controlled machines for the definition and inspection of the quality products. Coordinate measuring machine is one of the electrical chemical systems that is used for computer-aided quality assurance that we have discussed. We also had a laboratory demonstration in it, and we discussed rapid manufacturing. Rapid manufacturing these days, when we talk about computer integrated manufacturing, we cannot ignore the rapid manufacturing, rapid prototyping or additive manufacturing techniques, because additive is taking over the subtractive methods in a very fast pace. So, rapid manufacturing, it is a manufacturing process using CAD based automated additive manufacturing processes to construct parts that are used directly as finished products or components. Then we discussed about material handling and industry 4.0. In the last week, we discussed about the material handling systems, we discussed about the softwares, the plant layout softwares and product lifecycle management system. So, material handling, the definition is here. It is the movement, protection and storage and control of materials and products throughout the process of manufacture and distribution, consumption and disposal. We saw the various manufacturing platform, the soft manufacturing platform, that how computers are used for the material handling systems. Then in this week we discussed about industry 4.0, we discussed about the various industry 4.0 parameters and dimensions. The fourth industrial revolution represents a new technological paradigm where digital systems, the internet and the conventional industry will merge together, leading to a transformation of manufacturing system. So, this was all in the course computer integrated manufacturing. Thanks for being with us. It had been a wonderful experience for us as well. And Professor Ramkumar and I would like to thank all the participants, all the people who have supported us in this course, all of the staff members who have helped us to record the data, to edit the videos, and to the TAs as well, who have been very helpful in answering your questions in the forum and designing assignments. So, best of luck for the exams. Thank you so much.